Welcome to General Structures 2 and Lateral Forces. Listen to quiz question number 10. And it gives us the options of 1, 2, 3, and 4. And it says select the correct statements. A hyperbolic paraboloid is blah blah blah. Okay, so we'll go through these. And first I'm going to say what my opinion of hyperbolic paraboloids are. And to be honest, I actually had to look this up because I have never designed a hyperbolic paraboloid. And it was quite interesting. I did look back through because I wasn't sure exactly what they were, I looked through the study guide and I didn't see much on it. And maybe that's because I just skimmed it real quick. But it might have some great information on there. I haven't looked. Oh, there it is. Yes, I have since found it. It's on page 53. So you can read through there and see what it says about a hyperbolic paraboloid. It is saddle-shaped, so I will draw. Actually, you can look on page 53, and they show you what. Usually these are roofs. I won't say usually. A lot of time they're roof type systems, and I'll go ahead and draw that, and then I'll also draw another instance. So you'll have these two openings like that. And this will come down like that, and then oh, that was not good. Let's try again. This will come down smaller, then it'll come up like that, and then this kind of looks like that. And I'm over exaggerating it slightly. So it looks like that. And you make these roofs, and I remember a concrete book that had this in there, where it was I think it was a restaurant in Mexico that had something similar where maybe it had 3 of these put together and they were going, one was going that way, one was coming this way like I have drawn, and one was coming that way, and then maybe had a tower in the middle or something. But similarly, that's what it looks like. These are very good for economy. They're very economical. It's just the forming makes it non-economical. Very good use of the actual materials, but forming it might cost you 5 times more than it would to form and put up everything for just a straight, single one-way slab and whatnot. Anyways, that's my quick opinion. And another interesting thing is I went to Wikipedia and looked this up and skimmed over that site, but what you do is they have these towers is what they made back in the day, and they still do, but it's a straight line and it's another straight line, and they take a straight line and they just go around like that. And when wow, that was terrible. But go to Wikipedia and look this up, and you'll see that if you just keep on going around and slightly, and then you'll go the other way, and these ones will go the opposite way. It's kind of hard to show in this because I already twisted it around. But if the first one started like this, you'll space those every so often. The next ones will go opposite of that, like this, and you'll space them, and you'll go around and around, and go on there, and you'll see the towers they make up look like that, and they have a bunch, and they'll end up looking, after you make these all go, they'll look like something like that, and they form a lattice where it's a very nice looking economical structure because all these are straight. These lines are perfectly straight. It's just that they're at an angle and they're rotated, which I know it's hard to explain. The picture won't say 1,000 words, so go to Wikipedia, look up hyperbolic paraboloid structure or something like that, and it'll come up. So anyways, I think one important thing is these are straight. They're very economical. All these, it's like it's putting a straight line. And the same thing right here is that you can, at some point, you can put a straight line where it's just an instantaneous straight line. If you think of calculus, you're instantaneously rotating that line, and when that is the rotation of that line, that will create that shape. All right, that's enough of my terrible explanation, I'm sure. Once again, I would go to Wikipedia and look it up for yourself, I think, and read through the guide as well. All right, so back to the question on hand here. We have number 1. It says that a hyperbolic paraboloid can be formed by a series of straight lines, and yes, that is correct. That's exactly what we just said. That's what it is. 2 is a very stiff structure, and I believe that is also correct. Let me go through and see if is what it says, but I believe that's correct. There it is on page 54, the first column, the second paragraph, I guess the first paragraph that starts on this page, but about 3/4 the way, or halfway down. I believe I just read it. There it is. No, I'm not halfway down. It's about a fourth way down. Second sentence, it looks like it says, this two-way action makes hyperbolic paraboloids very stiff. So that would also be correct, like I assumed. Now let's go on to 3. 3 is economical in the use of material, and this is in the use of material. So key is in the use. Because remember, forming this material, M-A-T-E-R-I. Okay, my spelling may be wrong there. I wasn't paying attention. But remember, the forming of this may be more difficult. Now, if you come up with a great way to form this, for instance, I've seen some domes where they have always said, oh, forming domes is expensive. Well, I've seen a dome where they inflate this membrane in the middle and force air in there, so it'll hold that, and so much pressure that it will hold concrete up. So all they have to do is put concrete on the outside. They'll put their cage rebar around there, which is going to be expensive to form up. Obviously, your rebar cage, you have to make sure that those rebar are bent, or maybe you can do a welded wire fabric. That's easier. I don't know. I don't do that, but you could do that. And once again, the forming, I would say, is easy. Now, putting the rebar on there would be more difficult. Maybe you just do shotcrete all around that, as opposed to a poured concrete that's going to fall down. You just get shotcrete out, and hopefully you guys know what shotcrete is. I'm assuming that you do, but shotcrete, kind of, you have a hose or whatnot. Let's call it a gun. Let's make it look like a gun, too. And it will have concrete going in, and you kind of shoot, and it will stick. And you kind of put it all over the place, and it'll stick on there, and then you're good to go. Alright, so I forgot where. Oh, the forming. That was my whole point of doing that. Maybe you could form this cheaper, and if you could figure out a way to form a hyperbolic paraboloid very, very cheap, this might be one of the best structures to go with. Alright, key. It's economical in the use of material. Anyways, so let's go move on to number 4. It says, is curved downward in one direction and upward in another. And I think that makes sense. Downward right here, and it's upward right there. Sure, why not? That sounds good. So we're 1, 2, 3, 4, and 4. And as you can see, D is all the above. Let's check it in the back to make sure we got the right answer. I go to page 165, which I have tabbed, and it says D. Number 10 is D. See page 53. So if you have any other questions, read through page 53, and hopefully that will answer them all. I hope this was helpful, and I will see you on lesson 3.